All right, now let's take a look at Azure Key Vault, yet another interesting topic. And let us deep dive into the why, what, where, and how of Azure Key Vault. All right, so just a brief description of Azure Key Vault is Azure Key Vault is the combination of hardware security modules and cloud. So Azure Key Vault is nothing but a hardware security module solution that is proposed on cloud, such as Azure. So if you for all of those who don't know what exactly are hardware security modules, so hardware security modules, although today are not used that frequently, although might be used in legacy systems such as the payment card industry, PCI, for that fact. So these hardware security modules were earlier used to store cryptographic keys and important information, important identities, credentials, stuff like that, which gave the information to the user that only had access to these hardware security modules, that had a key to unlocking these hardware security modules. So there was a need to implement a concept like hardware security module on cloud, and that led to the birth of Azure Key Vault. So, why Azure Key Vault? What's the problem statement? So, let's say you are a developer that is building an application or an AI application for that matter of fact. Uh, and it's obviously because it's developing an AI application, it might be using some Azure Cognitive Services. And these Azure Cognitive Services are exposed as APIs, and you need to make calls to those APIs. And in the headers part of making those API calls, or even using the SDKs, you need to include your access keys, right? So you do not explicitly want to expose those access keys on as part of your code base. And so you're trying to search for a solution wherein you can securely store API keys and give access to only specific users. And on the other hand, you also do not want to expose or hard code your API keys in the code for your application. So you're trying to shoot two targets with one arrow of storing your API keys securely, making sure only the authorized individuals have an access to those API keys. And on the other hand, you also do not want to expose those API keys uh, because you're trying to store that code on maybe a public repository or a private repository or hosted on GitHub or stuff like that. So before we can move on to what exactly are Azure keywords and how do they work, there is one underlying concept that needs to be taken care of, and these are managed identities. So, what are managed identities? So, managed identity is an enterprise application within Azure Active Directory. So, Azure Active Directory is now called as Microsoft Entra ID. Entra ID's earlier name was Azure Active Directory. Right now, it's been rebranded as Entra ID. So, these are enterprise applications within Azure Active Directory, which can be used by an Azure resource to authenticate to any service that supports Azure AD authentication without having credentials in your code. So let's say, in the same way that give we create, let's say you are trying to create a storage account and then you are giving role-based access control to a user with the role as storage account contributor, right? So just in the same way that we give a role-based access control to uh, a user that is registered in a Rantra ID to act as a storage account contributor. Now, what if instead of that user, we wanted our web application, right? Let's say we're exposing your AI workload on an Azure web app. So let's say you want that Azure web app to have an access to the storage account. You want the code of that Azure web app to have an access to that storage account based on the principles of load-based access control. So earlier we were giving R back to a user. Right now it's an entity. It's not a user, but right now it's a resource, right? It's an Azure web app resource. It's the code of the Azure web app resource. Now, what if you want to achieve that same analogy based on this existent but non-living entity, such as an Azure web app? That's where managed identities kick in. So, managed identities are nothing but a user kind of representation of all of these living, non-living, but existing entities like an Azure web app in your Microsoft Entra ID directory, in your Azure Active Directory online. So, yep, there we go. That's a beautiful screenshot that lets you understand what the concept of a managed identity is all about. So, let's say your media services account is basically an Azure web app that's been deployed, and it's wanting to access a storage account. Now, while writing a code for this Azure web app that's been hosted on Azure, you haven't used the access keys or the primary connection string to have an access to the storage account. Rather, you have first of all created a managed identity for this, uh, your Azure web app in your Azure Active Directory. That's going to have the same analogy as that of a user when it's trying to access a storage account. So this Azure web app uses this managed identity to access a storage account. Similarly, if it wants, let's say your Azure web app is using a Azure Cognitive Services account, and as part of the Azure Cognitive Services account, you have stored the primary key and the secondary key of that Azure Cognitive Service account inside of a key vault. Then your Azure web app uses a managed identity and gains an access to the Azure Key Vault, and that Azure Key Vault gives the uh, Azure web app the keys for making API calls to your cognitive services resource or cognitive services account. That is where managed identity is used, and it's a very beautiful concept. It makes your application secure without having the need to store hard coded credentials into your code base. And that's where security kicks in. So there are two types of managed identities. One is your system assigned managed identity, and the second one is a user assigned managed identity. So a system assigned managed identity is created with the creation of a resource, whereas a user assigned managed identity is created explicitly on behalf of the by the user on behalf of the user consent. And because a system assigned identity is created with the creation of a resource, its lifecycle is attached with the lifecycle of the resource. Meaning, a system assigned identity will be deleted with the deletion of the associated resource. Whereas, because a user assigned identity is not closely attached to the resource because it's been created explicitly by the user, its lifecycle is different or is not bounded from the life cycle of the resource. Meaning, even if the resource gets deleted, the user assigned identity stays relevant, it stays existent. And a system assigned managed identity has a one to one relationship, meaning one system assigned identity can be applied to only one resource. Whereas a user assigned identity has a one to many relationship, meaning one user assigned identity can be used on multiple resources. So in this case, this managed identity, if it were a user assigned identity, it can be used on multiple Azure Web Apps, Azure Web App 1, Azure Web App 2, Azure Web App 3, or not only limited to Azure Web App, it can also be used on a function app or maybe a Cosmos DB resource, any resource that you can think of. Again, moving on, this is, again, beautiful architecture of, or let's say a short architecture of how you would use a managed identity to that is declared for an Azure app service to have an access for all of these cognitive services. So let's say you're trying to build an Azure AI workload that is hosted on an Azure app service or an Azure web app, uh, and the and you're trying to call various APIs of your cognitive services account. You're trying to call the computer vision API for detecting images, for analyzing images. You're trying to call the language API for performing text analysis, sentiment analysis, stuff like that. So all of these cognitive services are being used by our Azure web app. And because these cognitive services are exposed as APIs, and these are protected web APIs, meaning you need to include an authorization key. The keys of these cognitive services are stored in Azure Key Vault. So the flow goes something like this. If this Azure Web App code were to call these cognitive services, it would obviously require a primary key, right? And this primary key is stored in Azure Key Vault. So first of all, using a managed identity, it would talk to Azure Key Vault. It would say to Azure Key Vault, well, I have a managed identity, and my managed identity lets me access you. Now, because I want to call this cognitive service, please give me the primary key for this cognitive service. So Azure Key Vault verifies the managed entity and gives the primary key to the code of this Azure App Service. Now, the code of this Azure App Service uses this primary key from this Azure Key Vault to make a call to various APIs of the cognitive service resource, maybe computer vision resource, language resource, and stuff like that. Meaning that your code is secure. You're not hard coding any keys, any API keys, and you're keeping your code base as secure as possible, uh, and not providing and basically minimizing the surface vector for attack by any hacker or any malicious user. So yeah, I guess that's pretty much it for the video. Hope you enjoyed the video. It was a pretty conceptually heavy video, but yeah, rather a much needed one. So with this, let's quickly move on to the next set of videos.